Bismillahirrahmanirrahim. Today we will talk about exercise 4.4 of class 9th mathematics. I hope you all students are doing well and fine. Be safe and sound. For exercise 4.4 we have to recall some things that we have already know about from chapter number 2, that what are rational numbers and what are irrational numbers. So for that purpose, if we know all these values, if we know all these measurements, we can solve these questions. Exercise 4.4, question number 1, rationalize the denominator. The first part is 3/4 square root 3. See that from this question, rationalize the denominator. What is denominator here? This is numerator and this is denominator. We don't care about numerator because the requirement is only for denominator. For denominator, you have to rationalize it. So you first have to carefully see that, is this rational or irrational? You see that this is 4. Is this rational or irrational? Recall from chapter number 2, what are rational numbers and what are irrational numbers. The 4 is pure rational number, but the square root 3 is an irrational number. How square root 3 is an irrational number? I will tell you again. Square root 3, what will be the answer from your calculator? Let's see again what is the answer of square root 3 properly. So open your calculator and type square root 3. The answer will be 1.732050807568 and so on. See that the irrational number must be the non-terminating and non-recurring number. The non-terminating and non-recurring decimal part it contains. See that after the point, is there any recurring situation? Recurring means the specific numbers are going to be repeated again and again. See that 7, then 3, then 2, then 0, then 5, then 0, then 8. There is no any order of sequence for repeating the number. So this is non-recurring. And is there non-terminating? Terminating means after decimal part, it must be some terminating point, the break point. But this is going to be so and on and continues till infinite. So it is non-recurring and non-terminating decimal part it contains. So it is an irrational number. I hope you got it. And for this square root 3, he is saying that rationalize the denominator. For denominator, we see that only this square root 3 is irrational. So we have to rationalize it. We have to rationalize it. The conversion from an irrational number to rational number is called rationalization. Basically, we are going to do the rationalization. Rationalization means in the denominator, we just have to convert an irrational number to rational number. So there is an irrational number that is square root 3. We are going to convert only this irrational number that is in denominator. From the question statement, we are going to convert this part into rational part. So this process is known as rationalization. So we are going to do the rationalization. How? It is very simple and easy. you have to write numerator as it is, 4 square root 3 as it is. Only this irrational part you have to multiply and divide it. Multiply with that number and also divide with that number. See that there is no any difference in this and in this. You can cancel again and this is becomes. So we can do this part in mathematics, that we can multiply with same number and at the same time we can divide with same number. See that if there is 2, can I write this 2 as multiply by 3 and divided by 3? See no difference, because 2 3s are 6 divided by 3, 3 1s are 3, 3 2s are 6. Again the answer is 2. So when we multiply in the mathematics with same number and at the same time we are going to divide with that same number, so there is no any difference in that question. You are allowed to do this in any question. So to make it rational part, we are going to multiply with that irrational number and at the same time I am going to divide with that irrational number. Okay. Now 3 multiplied by square root 3, numerator is going to multiply with this numerator and denominator is going to multiply with this denominator, 4. Square root 3 multiplied by square root 3 means square root 3 square. Now you are going to solve this. You know that this square is going to be cancelled with this square root. So in numerator 3 square root 3 and in denominator 4 multiplied by that is 3. Now is there any cancellation possible here? Yes. 3 is going to cancel with this 3 and the answer is now is square root 3 divided by 4. See that in the answer. The denominator. Can you see any part that is irrational in the denominator? See that? No. But in numerator, you see that there is an irrational part, that is square root 3. So we are not going to concern about this because we are only concerned about denominator. So in the start of question, you see that there was an irrational part in denominator, but at the end of question, you see that there is no any part regarding an irrational value. So this is the answer and this is the methodology to make the irrational part to rational part. Now next part. (14) divided by square root 98. Now you have to rationalize the denominator. We have an irrational number that is square root 98. It is obviously an irrational number. You can check it from your calculator also. So you have to convert this denominator irrational part to a rational part. Mean that you have to do a rationalization here. So multiply this irrational part with this fraction and at the same time divide also. Okay, now 14 is going to multiply with this square root 98 and square root 98 is going to multiply with this square root 98, means that square root 98 whole square. So square is going to cancel with this square root. After that 14 square root 98 and in denominator that is 98. Now is there any cancellation, any cutting is possible? You can do it very well. Mean that 7 2s are 14, 7 1s are 7, 7 4s are 28 and after that 2 1s are 2, 2 7s are 14. So your answer will be in numerator that is square root 98 and denominator that is 7. See that your denominator part is rational. You can't see any irrational number in denominator. For numerator, there is no any matter. You must have to solve it regarding the denominator. So this was part number 2. I hope you understand it very well. And obviously part 3 after that. Denominator square root 8 and square root 27. There are 2 to 3 methods from which you can solve it now. For example, you can take LCM of square root 8 and after that square root of 27. You can solve it now very well, or you can simply solve it like previous methods. So for your convenience, I am going to solve. You see that there are 2 irrational numbers here. One is square root 8 and another is square root 27. So I am going to solve that square root 8 here and square root 27 here. So what I have to do that is multiply and divide with same irrational numbers. Square root 8, square root 27, and in denominator also square root 8, square root 27. Same method. So in numerator 6 square root 8, square root 27, and in denominator you see that square root 8 is going to multiply with this square root 8, square root 27 is going to multiply with this square root 27. So what will be happen? Square root 8 whole square and square root 27 also it is whole square. So square is going to cancel with this square root, square is going to cancel with this square root. So now in numerator 6 square root 8 square root 27, and in denominator that is 8 and 27. 8 multiplied by 27. After that 2 3s are 6, 2 4s are 8, again 3 1s are 3, 3 9s are 27. So in numerator that is square root 8 multiplied by square root 27, and in denominator that is 4 9s are 36. You see that square root, there is no irrational part in this denominator. There is an irrational part, but maybe you can find the answer in your book on the last pages, maybe some different from these values. So for that purpose you can solve furtherly, like you have to make this square root 8. You know that this square root 8 means after taking LCM of 8, 2 4s are 8, 2 2s are 4, 2 1s are 2. And for 27, 3 9s are 27, 3 3s are 9, 3 1s are 3. You can write it as 2 square and this 2 and this 3 square and this 3. You can write it, instead of square root 8, you can write it as 2 square multiplied by 2 and 3 square multiplied by 3, and in denominator that is 36. So for this multiply sign and for this multiply sign you can separate it as like square root 2 square multiplied by square root 2 and square root 3 square multiplied by square root 3. I can do this just because of these multiply signs. For positive sign and for negative sign I can't do these separations, as you know from your previous lectures. 36. This square is going to cancel with this square root, this square is going to cancel with this square root, and after that two square root 2 and multiply by 3 square root 3, and in denominator that is 36. So you can furtherly solve it like 2 1s are 2, 2 18s are, then 3 1s are 3, 3 6s are 18. So square root 2 multiplied by square root 3 that is square root 6, and in denominator that is 6. So this can be the answer in your book on the last pages, but this can be the answer because you can see that in this portion the denominator is away from any irrational number, and in this portion the same thing is happened. Now part 4, 1/3 plus 2 square root 5. the same question that you have to rationalize the denominator. I am again suggesting you that learn all the formulas that I have already told you from all the lectures, all the previous lectures. So see that what is the difference. The irrational part is square root 5, but it is multiply and add with, so this all value, the whole value is one thing, the combined thing. This whole value is basically irrational. You can calculate it like you can do it in your calculator, 3 plus 2 square root 5. There will be a complete and irrational number. So this complete value is an irrational number. So I can't do it like square root 5 that I'm going to multiply with this square root 5 and also going to divide with this square root 5, because this is not only the single irrational number, the whole thing is an irrational number. But for positive sign here or negative sign here, there must be one rule. We just have to fulfill it now. So what is the rule here for converting into irrational number to the rational number? The thing is, what is the change? That first you have to write it as on 1 over 3 plus 2 square root 5, and after that the conjugate of this one. Conjugate means that if 3 plus 2 square root 5, then its conjugate is, I hope you know about this thing, conjugate, very well from your exercise 2.5 in iota. You know that for 1 plus iota, the conjugate will be 1 minus iota. So 3 plus 2 square root 5, its conjugate must be 3 minus 2 square root 5. Or if this thing is 3 minus 2 square root 5, then its conjugate must be 3 plus 2 square root 5. So we just have to multiply and divide by its conjugate only. Only in the case if there is some positive sign or negative sign happens. So three plus 2 square root 5 here, and I am going to multiply and divide with conjugate. 3 minus 2 square root 5, and in denominator there is also 3 minus 2 square root 5. See that this is 3 plus 2 square root 5. Its conjugate is 3 minus 2 square root 5. I'm going to multiply with this and also divide with this. This is the rule. There is no any difference after applying this. There is no any difference. This is the same thing. By cancelling, this is again happens 1 over 3 plus 2 square root 5. Now think about it. I'm going to multiply 1 with 3 minus 2 square root 5. So it must be 3 minus 2 square root 5 in numerator. But what happens in the denominator? You see that, is there any formula is going to be made here? This is a plus b and this is a minus b. I hope you understand it very well. A plus b into a minus b mean that a square minus b square. So 3 square minus 2 square root 5 whole square. Now apply these squares. 3 minus 2 square root 5, and in denominator 3 square is 9 minus 2 square is 4, and square root 5 also contains square. So square is going to cancel with this square root, or you can do it like that. 2 and under root 5 are multiplied. So multiply contain combined power. So we can distribute this power just because that both values are multiplied. So I am writing it as, I have distributed this power just because they are multiplied. So this square is going to cancel with this square root, 3 minus 2 square root 5, and in denominator 9 minus 2 square, you know that what is the square of 2? 2 square is 4, and 4 is going to multiply with this 5. So 4 multiplied by 5, that is 20. So 9 minus 20, that is minus 11. What about this minus? You don't have to write it beneath in the denominator. You must have to write it in the center. 3 minus 2 square root 5 divided by 11, and minus is here. So this is the answer. You can see that there is no any irrational number remains in the denominator, but in the starting of the question you can see that there was an irrational number. Now this is rational number, 11 is rational number. After that, okay, part number 5 is similar, and I'm going to do part number 6. Now see that in this part, what is the difference? This is an irrational number, this is an irrational number, they are connected with this minus sign. So this whole value is an irrational number. Or you can check it by your calculator. Just apply, thus just put square root 5 minus square root 3 and check the answer. The answer will be an irrational number. That irrational number is in your denominator. So you must have to rationalize it. How? But with the same thing, same methodology, 2 divided by square root 5 minus square root 3. So now what we have to do it? Yes, we have to multiply and divide with this number? No, with its conjugate. So what will be the conjugate of square root 5 minus square root 3? Yes, you are right. Square root 5 minus square root 3, its conjugate must be square root 5 plus square root 3. So I am going to multiply with square root 5 plus square root 3 and also dividing with this thing, square root 5 plus square root 3. Okay. Now multiply it with, or you can simply write it as 2 in the bracket square root 5 plus square root 3, and the denominator. You can see that, is there any formula going to be made here? This is A, this is B, this is A, this is B, and between them there is plus sign, between them there is minus sign. So this is basically A minus B into A plus B. So what is A minus B into A plus B? Similarly, from previous question, you know that A minus B into A plus B, that is A square minus B square. So instead of A, there is square root 5 here. So mean that A square, mean that square root 5 square minus, instead of B, that is square root 3 square. So square is going to cancel with this square root, square is going to cancel with this square root, and in the denominator there, and the numerator square root 5 plus square root 3, and in denominator 5 minus 3. So 2 square root 5 plus square root 3 and denominator 5 minus 3, that is 2. Is there any cancellation going to be happen? Yes. 2 is cancelled with this 2. Square root 5 plus square root 3. See that. What is in the denominator? It is 1. Is 1 is a rational number or irrational number? Yes, obviously 1 is pure rational number, not an irrational number. So we have done it that we have rationalized our denominator. In the starting of question, the denominator was square root 5 minus square root 3, and in the end of the question, the denominator is only 1. You can write 1, or you can simply write it, because in the denominator, the 1 you can write it, or you don't want to write, there is not any major difference. So this is the answer. But one thing, see that square root 5 plus square root 3. In the previous lecture, I have already told you that square root 5 plus square root 3. Are they going to add? Can I write it as square root 8? No, I can't write it as. I can't add, even that, I can't subtract it. Is this square root 5 minus square root 3? That is square root 2? No. I have already told you this can't be happen. But multiplication can be happen. Multiplication can be happen here, and square root 5 multiplied by square root 3 mean that I am going to multiply 5 multiplied by 3, that is square root 15. Yes, this is happen. And also divide is also going to be happen. After that, part 7 and part 8 is same, so I'm going to solve part number 8. Square root 5 plus square root 3, and in denominator square root 5 minus square root 3. So you see that here is numerator is also an irrational, but we are not going to concern about numerator. We are only going to concern with denominator. You see that the denominator is an irrational number, square root 5 minus square root 3. Combined number is an irrational number. So to solve this question, we just have to multiply the denominator's conjugate, not numerator's conjugate, only denominator. You can see that square root 5 minus square root 3, its conjugate is square root 5 plus square root 3. Multiply it and also divide with same thing. You see that numerator is going to multiply with this numerator, square root 5 plus square root 3, and this square root 5 plus square root 3 mean that this is square root 5 plus square root 3 and this is same square root 5 plus square root 3. Mean that if x is going to multiply with this x, then it must be x square. Just because of this x power is 1, this x power is 1, so I can write it as x, the same basis for multiply, then 1 plus 1, that is x square. So what about this one? This is also the same thing. This contain power 1, this contain power 1, mean that this is square root 5 plus square root 3 whole square. And in denominator, the same thing, a minus b and a plus b, mean that a square minus b square. Square root 5 square minus square root 3 square. That is, square is going to cancel with this square root is going to cancel with this square root. But for this, which formula is going to open here? I can't write square root 5 plus square root 3 as square root 8. No, this is not true. This is a, this is b, and we are going to open the formula a plus b whole square. So what is a plus b whole square? Recall it. A plus b whole square is a square plus b square plus 2ab. Now this is a and this is b. Open it in the form of formula, that is a square, mean that square root 5 square plus b square, mean that square root 3 square plus 2a and b. The value of a is square root 5 and the value of b is square root 3. And in denominator, you see that this is 5 is independent and 3 is independent. 5 minus 3. Square is cancelled with this square root, same thing is here. So 5 plus 3 are independent. So I can write it as 5 plus 3 plus 2. Are they both going to multiply? Square root 5 and square root 3, can we multiply it? Yes, we can multiply, just because there is multiplication here. So square root 5 multiplied by square root 3 mean that square root 5 3s are 15, and in denominator 5 minus 3, that is 2. 5 plus 3, that is 8 plus 2 square root 15, and in denominator that is 2. Can I cancel this 2 with this square root 8? No, just because 8 is firstly bound with plus sign with this 2 square root 15. Or also I can't do 8 plus 2 because the first right is for multiplication according to the Demas. First is division, after that multiplication, after that addition. I can't do addition firstly. First it is multiply 2 with square root 15. So it is bound with this square root 15. So I can't do it 2 plus 8. So this is the thing. And another thing is, can I cancel this 2 with this 2? No, because this is bound with plus sign with this 8. Can I do this cancellation 2 with 8? No, I can't still do it. If this thing is independent by any phenomena, like you see that from both these values, is there anything common here? Just watch it and see it. Yes, 2 is common. So taking 2 common, 2 4s are 8. So 4 is here, plus this 2 is outside by taking 2 common. So square root 15. If I am going to multiply this 2 with this 4, this must be 8. And if I am going to multiply this 2 with this square root 15, this must be 2 square root 15, and in denominator that is 2. So we can cancel, yes, we can cancel this 2 with this 2 just because of this 2 is independent here. So this value can be cancelled with this 2. So our answer will be 4 plus square root 15. And in denominator, you can write 1. Or if you are not going to write 1, nothing makes any difference, because just we have achieved our goal. What was our goal? That rationalize the denominator. In denominator, we have received 1. So 1 is a rational number. So this was the answer. I hope you understand it very well. This was question number 1. And the remaining parts which we have left, you can easily go through it with. Just practice it. And for the question number 2 is very, very simple. Find the conjugate of mean that 3 plus square root 7. So what will be the conjugate of 3 plus square root 7? I hope you understand it. The conjugate is 3 minus square root 7, and that's it. For all the parts in question number 2, you just have to change the sign of irrational part. This part, you have to just change the sign of it. For part number, 3, 2 plus square root 3. So its conjugate is 2 minus square root 3. This is the answer. After that, if I'm going to solve the part number 6, 4 minus square root 15, just simple. What will be the conjugate of this one? You know that this is 4 minus square root 15, so it must be 4 plus square root 15, and so on. You can easily solve it, just you have to change the sign of every irrational part. Talking about question number 3 of exercise 4.4. You can simply just change the sign from question number 2 of an irrational part. So it is the conjugate. Question number 3 is, the first part is, if x is equal to 2 minus square root 3, find 1 over x. A very simple thing. You have given x is equal to 2 minus square root 3. So his demand is to find the value of 1 over x. For that purpose, you must have the value of x. So the value of x is 2 minus square root 3. The solution is to find the value of 1 over x. Just write it as, in the place of 1, you are going to write 1. In the place of x, that is in denominator. So what is the value of x? See that. What is the value of x? X is 2 minus square root 3. So is this the answer? 1 over 2 minus under root 3. Because according to the rule, we just have to rationalize the denominator, whether he is saying or not. This is not the acceptable situation. That denominator contains irrational part. You must have to solve it. Also, he is not saying this thing. So you have to solve it. 1 over 2 minus under root 3. How we can make this part rational, as it is irrational. Yes, you got it, yet we have multiply and divide with its conjugate. So its conjugate is, this is 2 minus under root 3, and its conjugate must be 2 plus under root 3. And in denominator is 2 plus under root 3. Again, 1 is going to multiply with this 2 plus square root 3, so this is 2 plus under root 3. and in denominator you can see that there is formula is going to be made. A minus b into a plus b mean that a square minus b square. So instead of a square I am going to write 2 square minus, for b square you have given the value b, that is square root 3, so square root 3 whole square. Square is going to cancel with this one, so 2 plus under root 3 in numerator, and in denominator that is 2 square, that is 4 minus 3. So 2 plus under root 3 in denominator, 4 minus 3, that is 1. This was 1 over x. See that 2 plus under root 3. In denominator you can write 1 or you are not going to write 1. This is up to you. This is the answer, as similar to your previous parts. Now after that, part 2 is just similar. Same is the procedure that you have going to do. I'm going to solve part number 3. I'm again telling you part number 2 is similar to part number 1 that we have solved recently. If you have any confusion, just concentrate on this part. This is just like part number 1. Now in this situation you have to find x plus 1 over x. You have given only the value of x, that is square root 3 plus 2. You just have to find x plus 1 over x. So we have the value of x. This is x is equal to square root 3 plus 2. But we don't have the value of 1 over x. So first we have to find the value of 1 over x. 1 over x is equal to 1. Similarly, just like from the previous part, 1 over x, the value of x is, you have already, square root 3 plus 2. Is this situation is acceptable? No. Just because of that, its denominator part is irrational. You got it? This denominator part is irrational. So what we have to do, think about it. Yes, we just have to make it rational, this part. So what we have to do it again and again, the things are going to repeat it, that we must have to multiply and divide with its conjugate. So the conjugate of square root 3 plus 2 is square root 3 minus 2, and in denominator square root 3 minus 2. So 1 over x is equal to 1 multiplied by square root 3 minus 2, that is only square root 3 minus 2, and in denominator square root 3 plus 2 and square root 3 minus 2 after multiplication, and it is a formula a plus b into a minus b. Again it is square root 3, mean that a square minus b square. So now 1 over x is equal to square root 3 minus 2 in numerator. In denominator, you see that square is going to cancel with this square root. This is 3 minus 2 square, that is 4. So 1 over x is equal to square root 3 minus 2, and in denominator 3 minus 4. You know very well the answer, that is minus 1. You know very well about that. For this minus, we just have to write it in the center, because this minus very well belongs to the numerator. 1 over x is equal to, just write in center, and after that apply bracket square root 3 minus 2. If you are not going to write this one here, you can't write it, but this situation is acceptable because its denominator is rational. So this is 1 over x and this is x. So can we do right now x plus 1 over x? Yes, now we can do it, because the question requirement is x plus 1 over x. He is saying that you just have to add x with 1 over x. We have x, value of x. Yes, we have value of 1 over x. Yes, it is. Now the value of x is square root 3 plus 2. This is x. After that, this is plus sign, you apply plus sign. After that, 1 over x. What is the value of 1 over x? Yes, this is the value of 1 over x. Value of 1 over x is minus under root 3 minus 2. This minus sign conflicts with this positive sign. This positive sign is of this. This minus sign is from 1 over x value. So now this plus sign is going to multiply with this. You know that x multiply positive into negative is negative. So square root 3 plus 2, that is minus. After that there is bracket. After minus sign, you must have to do every work within brackets, just because this minus sign must be affected inside the bracket. So x plus 1 over x is equal to square root 3 plus 2. Minus is going to multiply inside, so this is minus under root 3. Minus into minus, that is plus 2. See that which thing is going to cancel. Square root 3 positive, square root 3 negative. So x plus 1 over x, that is 2 plus 2, that is 4. This is the answer, and this was question number 3. Now we are moving towards question number 4. Question number 4 is just to simplify. 1 plus under root 2 and in denominator square root 5 plus square root 3 plus 1 minus square root 2 and in denominator square root 5 minus square root 3. Just see that. You just write it just to simplify. Is not saying that first you have to make it rational or make it irrational. This is an irrational denominator, this is an irrational denominator. Think about it that from your mind, is this situation is acceptable? No, this is not acceptable, because in this fraction and also in this fraction, there is an irrational part in denominator, also there is an irrational part in denominator. So what you have to do it now, you make it rational, and you must make it rational itself, this thing. So 1 plus under root 2, and in denominator that is square root 5 plus square root 3. How can we make this denominator irrational? Is rational. This is irrational, so you must have to multiply and divide it by its conjugate. Square root 5 plus square root 3, its conjugate is square root 5 minus square root 3, and in denominator square root 5 plus square root 3. This was this part. After that you can see that this is positive sign. And now I am going to solve this part. This is 1 minus under root 2 and in denominator square root 5 minus square root 3. But this thing is also, the denominator is an irrational, so multiply and divide with its conjugate. Its conjugate is square root 5 plus square root 3, and in denominator also square root 5 plus square root 3. Just apply brackets. This was this part. Good. You have to solve this part, after that plus and resemblance with this part. Similarly, parallelly, you have to solve it now. See that numerator is going to multiply with this numerator. How it is? 1 is going to multiply with this square root 5. This is square root 5. You know that algebraic multiplication. Now 1 is going to multiply with this minus under root 3. Positive into negative, that is negative under root 3. After that, now it's square root 2 turn. Square root 2 is multiplied with square root 5. What will be the answer of square root 2 multiplied by square root 5? Is this multiplication is possible? Square root 2 multiplied by square root 5? Yes, multiplication is possible. 2 5s are 10. So you can write is square root 10. After that, positive square root 2 and negative square root 3, positive into negative, that is negative. So square root 2 multiplied by square root 3, what will be the answer? 2 3s are 6, yes, is square root 6. And in denominator, see that a plus b into, sorry, this is a minus. This is positive and its conjugate is square root 5 minus square root 3 and it is square root 5 minus square root 3. Its conjugate, both are same. So a plus b into a minus b, it must be a square minus b square, mean that square root 5 square minus square root 3 square. After that, positive sign. And now this term, 1 is multiplied with this square root 5, mean that it's square root 5. 1 is going to multiply with this square root 3, mean that square root 3. Now minus square root 2 into positive square root 5, minus into plus, that is minus. 2 5s are 10, so square root 10. Minus square root 2 with positive square root 3, mean that minus square root 6. And in denominator, again, square root 5 minus square root 3, a minus b and a plus b, same is the situation. A minus b into a plus b, mean that a square minus b square, like square root 5 square minus square root 3 square. Square is cancelled with this square root, square is cancelled with this square root, same is the thing here. So now it will be square root 5 minus square root 3. Can I do that? Square root 5 minus square root 3 plus square root 10 minus square root 6 in calculator, and just I can't do it because this is another thing and this addition and subtraction can't be possible. I have already told you in the previous lectures, this square root, positive and negativity, is not possible. So I'm writing it as it is, square root 5 minus square root 3 plus square root 10 minus square root 6. In denominator, that is 5 minus 3, that is 2. And after that, positive sign, the square root 5 plus square root 3 minus square root 10 minus square root 6, and in denominator again 5 minus 3, that is 2. Now we just have to take LCM. So what will be the LCM? As this is 2 and this is also 2, you just have to write, if both the denominators are same, you can write all the values similar. So you can write this 2 is cancelled with this 2, and after that you can write the numerator as it is, square root 5 minus square root 3 plus square root 10 minus square root 6. After that, positive sign, and this thing is cancelled with this 2. Again I can write this thing as it is, square root 5 plus square root 3 minus square root 10 minus under root 6. Now this square root 5 and this square root 5. Can we add it? Yes, we can add, but not this square root 5 with this square root 5. Internally, we can't add the values internally. We can add only its coefficients. This square root 5 coefficient is 1, this square root 5 coefficient is 1, so this square root 5 plus this square root 5. How much? It is 2 square root 5. After that, minus under root 3 is cancelled with this positive under root 3. After that, plus under root 10 is cancelled with minus under root 10. After that, this minus under root 6 and with same sign, this minus under root 6. How much? This minus, this is minus 1, this is also minus 1. Minus 1 and minus 1 are minus 2. So I can write it as minus 2 under root 6. And in denominator, that is 2. Can I cancel this 2 with this 2? No, this 2 is not independent, this 2 is not independent. I can't cancel with this 2. But I can cancel if this 2 is independent here. So taking common 2, so square root 5 minus square root 6, and the denominator, that is 2. You can cancel this 2 with this 2. So this thing becomes square root 5 minus square root 6, and that's it. This was the answer. After that, part 2 of question number 4. Part 2 of question number 4 is 1 over 2 plus under root 3 plus 2 over under root 5 minus under root 3 plus 1 over 2 plus under root 5. Basically part 2 and part 3 are same, so I am going to solve the part number 2. You can solve part number 3 as on your own. See that there are 3 portions, and for 3 portions all the denominators are irrational. So you know what to do, that you first have to make all the denominators irrational to rational. For this part, 1 over 2 plus under root 3, its conjugate is, this is 2 plus under root 3, so 2 minus under root 3, and in denominator there is also 2 minus under root 3. This was this part. After that, this is positive sign. This positive sign is here, and after that in bracket I am writing 2 over under root 5 minus under root 3. But this thing is also an irrational, so you must have to make it rational. For that purpose, multiply and divide it by its conjugate, square root 5 plus square root 3, and in denominator square root 5 plus square root 3. After that, this positive sign here and this value is here. I am just mentioning with all the arrows that what is going to be happen gradually. So 1 over 2 plus under root 5, its conjugate is 2 minus under root 5 and 2 minus under root 5. So now multiply numerator with numerator, that is 2 minus under root 3, and denominator with denominator. You see that formula a plus b into a minus b, mean that a square like 2 square minus under root 3 square. After that it's plus sign, so 2 is going to multiply with square root 5 plus square root 3, and in denominator it is a minus b into a plus b, that is a square minus b square. After that, positive sign, 1 is going to multiply, so as it is happens, so a plus b into a minus b, that is 2 square minus under root 5 square. So square is going to cancel with this square root, this square is going to cancel with this square root, and this square is going to cancel with this square root. So now you have 2 minus under root 3, and in denominator 2 square, that is 4 minus 3 plus 2, and in denominator you have square root 5 plus square root 3. In denominator 5 minus 3, that is 2. After that 2 minus under root 5, in denominator 2 square, that is 4 minus, square is cancelled with this square root, that is 5. Can I cancel this 2 with this 2? Yes, because this 2 is independent. So I am going to cancel it. Now another step is 2 minus under root 3 and 4 minus 3, that is 1. Whether you can write it or not, it's up to you. Plus, this is simple, under root 5 plus under root 3, and after that plus 2 minus under root 5, and in the denominator see that 4 minus 5. What is the answer of 4 minus 5? Yes, you know it, that is minus 1. So what about this minus 1? This minus is not going to write here. This minus will be written in this part, in numerator. So 2 minus under root 3, I am not going to write this one because this one is here and not here. Same thing, square root 5 plus square root 3, and minus is going to concatenate with this positive sign. So plus into minus, that is minus. So after minus, you can write each and everything, you know it very well, in bracket, because this minus is going to implement, this minus is going to implement in numerator with all the values. So minus is going to multiply 2 minus under root 3 plus under root 5 plus under root 3 minus 2, and this is minus into minus plus under root 5. So what is going to happen? 2 is cancelled with this minus 2. Positive square root 3 is cancelled with this negative square root 3. So square root 5 plus square root 5. What is the answer of this square root 5 plus this square root 5? Is this square root 10? No. We can't add it as we just have to add their coefficients only. Its coefficient is 1, its coefficient is also 1. So it must be 2 under root 5. Because there is this under root 5 and this under root 5. How much? These are 2 under root 5. So this is the answer. I hope you understand all the questions. This was part number 2. You can solve part number 3 as it is. Just make rational parts. Just make a rational, just to rationalize the denominator. By this methodology, by multiplying its conjugate and divide it also with its conjugate. If you have any questions, any query, you can write it, you can ask it in the comments. And one thing, remember all the formulas, go through all the formulas daily. Thank you.